Good morning, students. So this is a class. Purpose of this class to create the awareness of the gate class. Then here we are going to handle the topic called thread and an operating system. And from an operating system, topic is a thread. So and then I request you all to write the gate examination, so which will be used for your higher studies. So those who all want to go for the higher studies, and then those who all want to pursue some higher studies in some reputed institutions like IIT and all. So that for that purpose, we are handling these topics. So gate, hope you all know what are all the basic things you have to prepare. So first of all, there is no topics from that outer from our syllabus. Okay, so what all that we are preparing for this 4 years, so the same topics will be repeated in the examinations also. So if you have preferred the computer science means, so most probably what are the core subjects that you are studied, like operating system and the DBMS, some C programming, Java. So this kind of questions will be asked. Like, the main important core papers they will be covered as a syllabus. Okay, so you can download. Hope you have someone have aware of that portions and all. So from that, hope you all listening some classes that they keep on the scheduling and then handling from the various subjects. So today I'm going to handle the topic called threats. Okay, so uh, already we covered about the operating system and all. So again, still I'm recalling that topic called thread. Okay, so what is thread? Basically, these are all the topics we are going to cover under this thread. So overview, multi-core programming, and then multi-threading models, and then thread libraries, implicit threading, and threading issues, operating system examples. Okay, so first we'll start with the objective. Okay, so what is the main use of the thread? So what is the utilization? Okay, so what kind of things we can able to do by using the threads? Okay, so first a thread which we are using to do some task. Okay, so that is the main thing. Okay, so for the small kind of activities or for small kind of things that we are doing using the threads, so that is the main things. So main objective here to handling this topic is to introduce the notations of the thread. Okay, so you have to know the fundamentals of CPU utilization. Okay, how the CPU utilization is happening, so how it performing that task, so how it equally distributing that task and all. Okay, so that is the basic thing you have to know. So these are all the main objectives. To first next to discuss about the APIs. Okay, so what are all the APIs we are using for the thread? Okay, so to process the thread by using in Windows, what are all the Java thread libraries we are using for that, and then to explore the several strategies that provides the implicit threading. Okay, so what are the main strategies we are using for provide the implicit threads, and to examine the issues. Okay, so if it is any issues happen when you are creating the thread, and then when you are handling the thread, so how to examine that? Okay, so next to cover the operating system supports for the thread in the Windows and Linux. Okay, so these are all the main objective of this topic. Okay, so first, what is the motivation? Motivation is kind of why we are using the thread. Okay, so in the model application, you know how much it is useful. Thread is how much is useful. So you know how much the system has been evolved, and then how the operating system has been evolved. So the most important part, most important evaluation, the supporting thing is the thread. Okay, so nowadays when you're creating that code, so thread will be the most important factor which used to, because we all know, okay, so how we are improving our system or improving our operating system through this scalability in every aspect. So because of we are equally splitting the task. Okay, so for that thread, thread is the most important, thread plays the most important part in it. Okay, so the thread is the creating the more impact on the modern applications. Okay, so first thing, next the thread runs within that application itself. Okay, we are creating that application, so immediately it creates some impact on it. Okay, so nowadays when we are creating that coding, so without thread you cannot handle any kind of applications. Okay, so for example, even though if you want to wait for some time, okay, so most probably the thread will be used to for the waiting purpose, and then to handle some small tasks and all. Okay, so for everything. Okay, so that's what they are creating for the updating the display and then fetch the data, spelling the check. These are all the some parts. Okay, so but many for the many things for the many tasks we are handling the task we are using the threads. Okay, so next to the process creation is why we are not going for the processor, even though the process is also one of the dividing the task and all. Okay, so for example, if you're doing some task, okay, so it's given by us to the operating system, so that will be considered as a process. Okay, so that means process. That process will be handled by the multiprocessor. Okay, the single process will be handled by the multiprocessor. For that we have to create this sub process and all. Okay, so that process is a heavyweight process, that we call it as a heavyweight process. Okay, so what is the difference? So process also we are using for the multi-process, we are also using for the dividing the task and then performing that, but still it is a heavyweight process. Okay, so out of the large amount of code of block and all. Okay, so but thread, it has the lightweight process. Okay, so it handles only the small it has a small code of unit, but still it has its own properties like own memory space and then everything. Okay, so but still it is a lightweight process. That means still if you have the task, if you're splitting into the multiple task, from that particular task if you want to do again some operation. Okay, so that operation may be a heavy, it may take some time. Okay, so to divide that we are using the thread. Okay, so that is a use of the uh, thread. Okay, so comparing with that process, thread will be more considerable. Okay, so for the task that you are performing, some lightweight task we are performing, so thread will be the more considerable. So next, it can simplify the code and increase the efficiency. Okay, so many things. Okay, so when you are going for the coding, so reusability is the first thing. Okay, so when you are creating that code, you have to consider about the reusability. Okay, so because it can reduce the coding, right? So the same thing, it will increase the efficiency. Okay, so the reusability. At the same time, if you are using this kind of lightweight process, it can improve the efficiency of the coding. Okay, so that you can able to perform quickly. Okay, so that's how you can able to improve the efficiency. Okay, so next, kernels are the generally multi-threaded. Okay, so kernels means what we call as a kernel. So what are all the operations that we are performing to the operating system? So operating system means some of the things. Okay, so what are all the internal things of the operating system that we cannot able to handle by the users? Okay, so that cannot be handled by the users. So that we have to handle it through the kernels. Okay, so through the kernels only we can able to fetch the data from the operating system, what are the internals memory and all. It cannot be handled by the users. Okay, it can be only handled by the kernels by defaultly. So kernels are generally handled by the threads. Okay, so by using the multi-thread. So these are all the most important things that you have to focus about the threading. Okay, so how much it is useful. Okay, so that we call it as a motivation. So next one, so multi-threaded server architecture. Okay, so multi-threaded server architecture. So how it actually works through the server. So the client first initially requests for the server. That means what are all the things that we need to fetch from the server. So that request will be sent to the create as a server. Okay, which used to create as a server thread. Okay, so thread will be different types of thread that will be that we can see later. Okay, so what are all the requests that we are given to the server? That means we can fetch the data, we can view the some data, and then we can read, write. What are the requests that we are sending to the server? So based on that, our task, it will create the new thread to provide the service to that request which given by the client. Okay. Again, it will keep on resume that listening for the additional client request and all. So for all the requests that you are giving based on the task, it can create the thread. Okay, so for that task to perform that task, how many threads it needed, so it will automatically create that thread and all. Okay, so these are all the. This is actually the multi-threading server architecture. What are the benefits? What are the main benefits of a thread? Okay, so first thing is the responsiveness. Okay, so it may allow a continued execution if part of the process is blocked. Okay, so even though part of the execution is blocked, it will continually it will continue the execution. It will never stop that. It will never block the things. So it is especially important for the user interface. Okay. So next, what is resource sharing? So another benefit is a resource sharing. Okay. The thread shares the resources of the process easier than the shared memory on the message passing. So we all know, okay, so if you are handling the multi-threading means, so resource plays a major role. Okay, so without resource, the thread cannot able to access the data from the user and all. Okay, so what kind of actions it need to perform, that can be decided by using the resource only, sharing the resource only. Okay, so here comparatively with the with other process and then task and all, so threads make it as easier. Okay, so it is easier than the shared memory. Okay, so if you are formally having the shared memory means, so that will be divided by some other process and all. Okay, so here the thread shares the resource of the process. Okay, so in that process it can be divided into multiple resources. Okay, so that will be shared by the threads. Okay, so it is making easier than the shared memory. Okay, so next, the third one is the economy. Economy is another thing. Creating the thread is a lower cost than the creating the process and all. Okay, so and then context switching is the most important thing. So that is a major disadvantage in the process. So context switching means if it is one process initiated that task, so immediately another process wants to request based on the priority. If it is if you are switching to that another process means that we call it as a context switching, because all the resource have we have to switch and then many things we have to do. So because of that heavy weight process, so context switching in the process makes a more cost. Okay, so and then it is not that much efficiency also. So thread, we all know it is a lightweight process, so that the context switching may not cost that much comparatively with the process. How you are, how the context switch happens in the process. In context is happening, the thread is cheaper than the process context switch. Okay, so this is how we call it as a economic. The fourth benefit is a scalability. Okay, so scalability we all know. Okay, so the process can take the advantage of multi-process architecture, so that the scalability will be high. Okay, so anytime we can able to um, perform that operation, so the efficiency will be more high. Automatically we can achieve that scalability also. Okay, so these are all the benefits of using the thread. So what is the multi-core programming? So multi-core or multiprocessor, we call it as a multiprocessor system, putting the pressure on the programmers. What are the challenges included when you are handling for the multiprocessor? So first thing is about the dividing the activities. Okay, so how we are equally dividing that activities to all the process. Okay, so because if you are handling one task, you have to equally distribute it as a different process. Okay, so if you are giving the more task to that particular process means it may create some issues. Okay, so to complete the process may take some time. Okay, so that is the main reason we are splitting the task, equally splitting the task. Okay, so dividing activity is the most important factor in that. So that is the most challenging thing. Next thing, balancing. Okay, so we are equally balancing. Okay, so based on the efficiency, based on the time, so you have need to balance that data. Okay, so next one is the data splitting. So another thing, we have to dividing the activities based on the data also. Okay, so if one task which never needed that data from that resource means, so it may complete it quickly. Okay, so that we have to give some other task. It's based on that data. Okay, so it may take some time. So that all the process can equally complete the process on time. Okay, so that's why how the data splitting is playing the major role. Okay, so data splitting, so as well as we have to look so whether the data splitting may cause some other issues. Okay, so because once if it is a resource handling by the some other process, will not be shared to the some other processes and all. Okay, so that data splitting is plays also the major role. So that is also one of the most challenging thing you're going for the multi-core programming. Next one is the data dependency. So how it dependent on that particular data. Okay, so how that if you want to complete some task, so you need some data. Okay, so how you are dependent on that data. Okay, so without that data, how you can handle some other things. Okay, if this the data is not available, so you can able to manage for some time. So these are all the things we have to look out. Okay, Next one is testing and debugging. Also, what is testing and debugging? So we all know, okay, so once if you're completing the process, then you have to look whether the actual data comparing with the uh, required data. Okay, so whether after completing the process, we need to check that, okay, so required data as well as with the uh, actual data. Okay, so if it is any changes occurs means, so obviously there is no required result occurred. Okay, so we can easily identify some of the problem may occurred like that. Okay, so the debugging finally how we are equally testing these parts, whether it provided the expected result, and then what kind of errors may occur when you are handling this kind of issues. Okay, so how we are identifying that errors. Okay, so that we call it as a debugging. Okay, so these are all the major challenges will face when you're going for the multi-core programming and all. Okay. So then what is the parallelism? Okay, so parallelism and concurrency. Hope you know the parallelism implies the system can perform more than one task simultaneously. That we call it as a parallelism. So concurrency support more than one task making the progress. That we call it as a concurrency. So the parallelism, so more than one task, it can perform more simultaneously. Okay, so concurrency means not only giving the priority to that particular task, so it can give a priority to all the other tasks. It simultaneously try to execute all other process, and then so if it is one process taking the more time, means immediately it will stop that and it will provide data to some other task. That we call it as concurrency. A single processor, a core scheduler providing the concurrency. Okay, so most probably if it is going for the multiprocessor, the parallelism will be needed. So you can you're going for the some diagram, you can easily identify that. Okay, so what are the types of parallelism? Data parallelism and task parallelism. Data parallelism means so you know distributing the data across the multiple cores or the same operations on each. So this we call it as a data parallelism. So task parallelism again distributing the threads. Okay, so how many threads we needed for this particular task? Okay, so how many threads we are going to use across that course, and then each thread performing the unique operations. So how it much it is going to use that data, and then what kind of task is going to perform. So how we are split it equally or not. So these are all the things we have to check. Okay, so this we call it as a task parallelism. Probably when you're going for the multi-core programming, these two kind of parallelism are there. So data parallelism and task parallelism. So as of threads grows, so does the architectural supports for the threading. Okay, so by default, CPU have the cores as well as the hardware threads. So these are all some examples for the hardware threads: Oracle, Spark 4 and 8 cores and 8 hardware threads per core. Okay, so even though the user is not using the thread, so if you are creating some applications and then some of the uh, web applications that you are creating means so that we can implement our user threads. Okay, so but by default for the operating system, if you're handling for the hardware things means so there you have to go for some default threads. So that means kernel threads. Okay, so these are all the some examples of it. Okay, so this is what I told. This is a diagram for concurrency and parallelism. So concurrency, this you can see. I already told the example. The concurrency most probably for the single core application. Here you can see, you can clearly see the difference between the parallelism and concurrency. So concurrent means so even though single core is happening means that we can implement. Most probably we can go for the concurrency. So here you can see there is a task one is there in many places. So if it is a task one is having the more time, that means it may take more time means so we are giving some chance to the task one, and immediately we are stopping the task one, and we are giving the opportunity to the task two, task three, task four. Again, we are coming to the task one. Okay, so this we already saw it in the job scheduling, right? So in the job scheduling, we are equally giving the priority to the all of the tasks to complete it, so that the all of the tasks may get some chances to complete it. Okay, so this we call it as if you are going for the single core, so the concurrency is the most important thing, which is giving the priority to all of the tasks and then trying to complete all of the tasks. Okay, so because we already saw some of the tasks may have less time to complete, so that the task should have to wait for the long time. Because of the priority, some tasks may have higher execution time, so that it will keep on executing. So the task which having the lesser time to complete, so it should have to wait for a long time. Okay, so that's why we are going for this kind of concurrency is the most important thing when you're going for the single core. So the parallelism we know. Okay, so we have the more than one core means equally we are trying to execute the task into the dual core and all. Okay, so this comparison between the concurrence when you are going for the concurrency, when you are coming for the parallelism. So this is a diagrammatic representation. Means how the single and multi-threaded process is happening. Okay, so this is what I told. Okay, so thread also having its own code block, and then data, and then files, and then it has its own registers and stack. Here in this diagram, you can clearly see each and every thread having its own coding part data. Okay, so this is an example for the single thread and then multi-threaded process. Okay, so when you are going for that uh, multi-threading also, so for the common the code data and files having that common common things. Okay, so but it has its own registers and stack, so that we can easily identify that thread, and then we can make it use of it. Okay, so this is a diagram for the single thread and then multi-thread programming. Next, you can see the what is Amdahl's law. So Amdahl's law, it's nothing about um, it's used to identify how it's performing. Okay, so how the application is performing, how parallel things are happening. Okay, so identifying that for the each and everything, even though if you're going for the testing or some other thing, so how quickly it performs. Okay, so the application how quickly it performs. We have to calculate that. Okay, so how reusability has happened. So how efficiency is that. So based on that efficiency and then timing, so then only you can able to identify the cost of the program. Okay, so that's why I'm telling. So most important factor of the when you're creating for going for the application, reusability is the most important thing, so that you can reduce the number of codings. Okay, so when you're reducing the number of codings, so automatically you can make it as a efficiency. Okay, so efficiency converts as a cost. Okay, so how easily you are creating that program, so how reducing the code makes as a cost. Okay, so if you are going for the long program, means it costs more thing. Okay, so same time it may execute, the execution time may be extended. Okay, so if you are going for the if you are completing it as a small coding means, and you are going for the reusability. Why you are telling again and again about the reusability means, so you're not going to perform the same task. You're going to give the different types of inputs and all. For that everything you have no need to create that program again and again. You no need to create the program for that. Okay, so when you have created the same program, so it should suit that for the all other activities. Okay, so that's why reusability is using. Okay, so it reduces the time we are spending for that, and then it makes the efficiency. So in future, so there is no need to change property. Okay, so this is a most important thing. So that's how lambda's law is, how we are increasing the speed up. Okay, so how speed up with the process is that. Okay, so here I can see based on the calculation, if this application is 75% parallel and 25% serial, moving from the 1 to 2 cores. Okay, so I have compared that portions we applied in that previous thing. Okay, so how the parallel components is happening. Okay, so how much serial the parallel components, we should have to concentrate on that. Okay, so parallelism is the most important thing. So nowadays we are using the multi-core architecture. Okay, so that the parallelism is default thing. Okay, so when you're going to the coding also, you have to apply those parallelism. Okay, so then only we can able to improve the speed up. Okay, so the Amdahl's law is supporting that course. Here you can see the types of threads. What is the user thread and kernel thread? Okay, so user thread, it's management done by the user thread library. Okay, so what are all the threads which created by the user? When you're creating the applications, many things to perform the task you can create. So for the waiting to display the some things, for everything you can create the thread. Okay, so those threads we call it as the user threads. So the three primary threads libraries for using for that POSIX thread, and then Windows thread, and then Java thread. Okay, so these are all the primary thread libraries when you're going for the user thread. So the kernel thread is supported by the kernel. Okay, so I already told the operating system by default it has some kernel threads. It can be all the operating system, because we know behind the scene. So the operating system is keep on running some things. Okay, so which could be completely handled by the kernel threads. Okay, so if we are user want to access some data from the operating system, means we cannot able to directly approach them. Okay, so we can approach them through the kernel threads only. Okay, so we have to give the request. The kernel thread should have to create that another thread for that for our request. So if it is accepted, means then only we can go for that. Okay, so that too we having access to read some data. We cannot modify any data which is inside of that operating system. Okay, so this is different types of the examples for that kernel threads. We know all about the operating systems and all. Gives Windows, Solaris, Linux, and all. So what are all the multi-threading models are there? Okay, so threads have been you saw what is threads and all. Okay, so what are all the multi-threading models are there? Uh, what are the approaches we are following for that many to one, one to one, many to many? Okay, so these are all the different types of multi-threading models we have. So first we'll start with the many to one. Here, the many to one means we all know. Okay, so if we are sending some request for the user, so it could be handled by the kernel thread. So that only we can able to operate the operating system and all. For example, for the memory management, everything. Okay. So here, how this approach is happening. Okay, so how the interaction between the user thread and the kernel thread is happening. So that's how this approaches are many to one, one to one, and all using. Here, many to one means so here the many user threads are there. So only one kernel threads are there to respond for that user threads. Okay, so the mapping is like that: many user threads and one kernel threads. Okay, so one thread blocking all the users. So what is the disadvantage of it? Means so if it is a many threads or user threads are requesting, means so at the time the kernel threads will accept only one thread only. Okay, so that all the threads will be in the block state for it may for sometimes. Okay, so this will reduce the efficiency of that system. Okay, so obviously it will reduce. No. So many user threads are there, means so only one kernel threads are there to respond for all the user thread, means so at a time only one response can able to provide by the kernel thread. So that obviously all other threads should have to wait, will be in the blocking state, so that the efficiency will decrease. Okay, so this is what we call it as a many to one. It has a many disadvantage. So still we are using these threads and the Solaris green threads and then GNU portable threads and all. So next approach is the one-to-one thread. Okay, so here the user threads are there, and then equally for that every user thread equally we have the kernel threads. Okay, so for that response. Okay, so it has advantage comparatively many to one approach. So one-to-one approach having the many advantage. Okay, so it is a more concurrent than the many to. So, but number of thread process sometimes restricted due to overhead. Okay, so and also so imagine in case if it is user thread is not performing, okay, if it is not accessing for the request, means the kernel thread will be wasted. Okay, so kernel thread handling is the most important thing. Okay, so you can just imagine if you're doing the separate kernel thread for all the user thread, means so the cost will be more high. Okay, so cost will be more high, and then obviously the operating system should be the more efficient for that. Okay, so then only it could happen, otherwise is not preferable. Okay, so comparatively many to one, one to one is more concurrency, but still it has many disadvantages. Still this uh, for using for some other operating system like Windows in previous versions and all, not now. So Linux, Solaris, and all, and later all they use these approaches, but it's quite costly compared with the other approaches. Okay, so next we can move for the many to many models. Okay, so what is many to many? So we are creating the user thread, so as well as we are creating the kernel thread. So any threads can access the any kernels. Okay, so that no need to create the equal kernels for the users. Okay, so if it is 10 user threads we having means so 5 kernel threads may be available, means it will be more efficient. So all there is no separately, we are not giving that kernel thread for the separate user thread. Okay, so we are giving totally, we are giving the 5 kernel threads, totally we are giving the 10 user threads. So all other threads, if it is what all the user threads are needed, so which kernel, if it is a kernel thread is so not which is in the free condition means so it can easily approach it, so that it will not take that much time. Okay, so even though if it is a kernel thread may release that user thread after completing that request. Okay, so on the time which is in the waiting queue, so we'll access that kernel thread. Okay, so comparatively previous one, so there is no need to give the separate kernel thread for the all the user thread. Okay, so at the same time, so here we are having the multiple kernel threads. Okay, so that user thread no need to wait for the long time. So what are all the disadvantage we had in that one-to-one and many-to-one? So we are trying to that, that means trying to recover that disadvantages. Okay, so all of the disadvantages we had in the previous approaches. Okay, so this advantage. So currently we are using this approach. We are using the hybrid also that we can see in the next part. So this is somewhat comparatively the previous approaches. This is somewhat useful, right? So next one is a two-level model. So what is a two-level model? Here, this is what I told earlier. It is similar to the M2 and accept. Okay, so here we can use the many to many, and then also we can use the one to one. Okay, so based on that your approaches. Okay, so it is not enough means so it is some user thread are required separately for the kernel thread means that we can also be provided. So this is what we are using currently. Okay, so this we call it as a two-level model. What are the threading issues are there? Okay, so we see this elaborately. Okay, so how it threading issues will occur. So we'll discuss that. We'll discuss about it. So just this is an overview. So based on what are all the threading issues may occur. So first is semantic of forks and execution system calls. And second about the signal handling, whether it is asynchronous or synchronous. And with are the threading cancellation of target thread. Okay. So it has a synchronous and also the deferred type. The next one is the thread local storage, and last one is the scheduler activations. Okay. So these are all the most important issues may occur in using the threads. Okay, so one by one we can see. So first we'll start with the semantic of fork and execution. So we all know fork which used to create that child class. Okay, so to initiate that class we are using that fork class. So we all know the fork class duplicates only the calling threads on the all threads. Okay, so we can also duplicate. Because of that, may create some issues. Okay, so which is not necessarily needed. So if you're creating that duplicate thread means it may create some problem. Right? So that is the one thing. So next was the execution. We all know. So to identify that running process, so to make it as a running as a state, so we are using that execution. Okay. So if there's a one thread is created means to make it as a running process, we are using the execution. It usually works as normal. Replace the running process, including the all the threads. So what are the threads we have created? It will include all the threads as a running process. So may create some issues. So this is creating of the fork and execution. You have to concentrate on that. You have to make sure we should not create all the threads at same time. So what are the threads we needed on the task? We have to create that thread. Okay. So after that, based on the task we have to create. Okay. So initially we wanted to create and duplicate threads, and then it may go for the running process now. Okay. So this may create some issues. Next one is the signal handling. Yeah, hold on. The signal handling is the most important thing to identify which process is waiting state and which process will be in the ready state. So these is signals are used to notify the process which in the particular event has occurred. Okay. The signal handler is used to process the signal. A signal is generated by the particular event, obviously. So the signal is delivered to the process. The signal is handled by one of the two signal handlers, the default and user defined. Okay. So default handler that kernels run when the handling the signal. Every signal has a default handler that kernels run in the run when the handling the signals. Okay. So user defined signal handlers can override the default. Okay. So there is a issue we have. So user defined signal means the overriding means okay, so which function is created in the parent class. So that same function will be created by the another class subclass. You can take it as a subclass. So if it is a class we are that means if it is a function we are calling for the from the parents class means the same function name which is available in the subclass. If you are creating the object for the child class, and then if you are trying to access that function from the base class means so it cannot be, it can be overridden by the child class which you are having that function in the child class. Okay, so that we call it as a override. So obviously the user defined signal will override the default signal. Okay, so this is what will happen. This is the issues we are facing in that handling the signal. So for the single thread signal delivered to the process. Okay, so what kind of signal? User defined. Whatever the user signal is, so overriding the data, no, right? So it may create some problem. Then where should a signal be delivered for the multi-thread? So it should have to deliver the signal to the thread to which signal applies. Okay, it should not change it, right? So deliver the signal to every thread in the process and deliver the signal to the certain threads in the process. Okay, so for all the thread is available, so we have to decide for which thread we have to give the signal. Sometimes we should no need to give the signal to every threads. So assign the specific thread to receive all the signals for access and then to deliver. So these are all the questions we have, right? Okay. So how we are to deliver the signal? Multi-threading and then how we have to deliver the signal? Okay, so we have to give the signal to all the threads. We have to give the signal to the certain threads, or we have to assign the separate thread for signaling. So these are all the questions we have, right? Okay. So for that, these are all the issues may occur in the signal handling. Excuse me. So next one is a thread cancellation. So what is a thread cancellation? Sometimes if we never needed, if we come to know that thread is no longer needed means so that thread will be cancelled forcefully by the users. Okay, so the thread to be cancelled is we call it as a thread, a target thread. Okay, so sometimes the thread which is not required, so forcefully we are trying to cancel the thread. Okay, so that's what the two general approaches are there. Asynchronous cancellation means it terminates the target thread immediately. Okay, so default cancellation means once again. And default cancellation means allow the target thread to periodically check if it should be cancelled. Okay, so these are two types of approaches. Going for the thread cancellation. First, asynchronization means it terminates the target thread immediately. So default cancellation means allow the target thread to periodically check if it should be cancelled. Okay. So pthread code to create and cancel the thread. Okay. So these are all the thread cancellation. So what will happen means if you are going for that asynchronous means if you're forcefully cancelling that particular thread means occurring, so that thread may not clean up that data which is already invoked. Okay, so if handling for some data, if access some data means, so if you're on that time, if you're forcefully canceling the thread means it may not release the data, right? Okay, so it may not release the data. So that data may be needed by some other threads. So that thread might be in waiting state. So that's what we are telling. Asynchronous means forcefully we not stop that thread immediately. Okay. So you have to check whether it is an available state. So we are requesting it to stop. So when it is get the signal for the cancellation, what are all the things it handling, it should have to release all those things, and then it should have to release after that. Okay. So this we have to. These are all the another issues we having in the facing in the thread cancellation. We have to be very conscious about the thread cancellation. Immediately we should not stop it. Okay. It may cause some problems, right? So next one is the thread local storage. Again, based on that local storage, we have facing the many user issues like thread local storage allows each thread to have its own copy of data, right? So it is useful when you not have the control over the threads creation process that is using when the thread pool and all. So, but different from local variables, as local variables visible only during the single function innovation. Okay, so thread local storage visible across the function innovation, right? So we have to look about the what are the local variables that are. Okay, so we have for the using that across that function innovation means it will not be required, right? It's similar to the stats data. The TLS is unique to the each thread. It should be unique. Otherwise, it will not be useful. Okay. So it may create some problem like that. Okay, so create local storage should have to create that local variable. So it should be visible only during the single function innovations. So it should not be visible for across the invocations. Okay, so it should be unique. Okay, so these are all the things we have to look. Next one, uh, scheduler activities. Okay, so what is a scheduler activation? This is what I told. Okay, so how it should be accessed. Okay, so whether we can able to directly access the kernel type means so how it require that communication. Okay, so to maintain that appropriate number of kernel threads to locate to the applications, how it typically use intermediated data structure between the user and kernel threads, how it converted as a lightweight process, so how it virtually process, which process can be scheduled user, and what kind of schedule activities provides the upcalls, the communication mechanism of kernel to the upcall handler. Upcall handler means this communication allows an application to maintain the correct number of kernel threads. Okay, so this is how it need to communicate with each other. Okay, how it converts as a lightweight process. Okay, so how it converts as a lightweight process, and then how the activation occurs. Okay, so intermediate should be some there, right? Okay, so lightweight process of we have to create it. Okay, so that lightweight attached to the kernel thread. Okay. So that we can easily the user thread can access that intermediator rather than so lightweight process is intermediated between the user thread and the kernel thread. Okay, so that we call it as a call handler. So this is how we are handling that. So these are all the issues we are having in that threads. Okay. Next we can finally end up with the operating system examples. Okay, so in Windows, what are all the threads we are using? In Linux, what kind of real-time threads we are using? So how it is useful for that. Okay, so here in Windows thread, you can see Windows implements the Windows API that's called as the Windows 98, WinNT, and then Win 2000. So it implements the one-to-one mapping. Okay, so one-to-one mapping kernel level. So that's what we already told. Okay, so nowadays we are using the hybrid, right? Okay, so once again. Okay, so sometimes we are going for the hybrid. Nowadays we are using that hybrid, and many to many and all. So some of the things on mapping and kernels will be at a one-to-one approach. So each thread containing the thread ID, and then here, so in Windows thread, how it has. So each thread contains a thread ID and then registered set representing the state of process, and separate users and kernel stacks for when threads are run in user mode or kernel mode. So and then the private data storage area used by the runtime libraries and then dynamic link libraries. So these are all the things which contained in the thread when you're using for going for the Windows thread. So the registers set stack and the private storage area are known as the content of the sorry, okay, like when you're going for the Windows thread, so these are all the things you have to look at. Okay, so still we are using this kind of runtime libraries and many runtime libraries and dynamic libraries. We already seen there is a different types of libraries when you're going for the user also. So there is some separate Windows libraries are there. Okay, so Java libraries and then Windows libraries are there. That means threads are there they're using. So that Windows thread will be useful for separately for the Windows Auto using for the Windows operating system. So the primary data structures of the thread includes that means the Windows thread includes E-thread. Okay, so these are all the primarily we are using for that Windows thread. E-thread exclusive thread block. Okay, so includes the pointer process to which thread belongs to be K-thread in the kernel space. Okay, so E-thread means it includes the pointer process which thread belongs to the K-thread, that is kernel thread. Okay, so next K-thread, we all know the kernel thread block scheduling and synchronization into the kernel mode stack pointers to TEB kernel space. So TEB means a thread environmental block. It has the own thread ID, user mode stack, and then which we've seen already, right? Thread environment means it may have the separate thread ID and all. So this is some data structure of that Windows thread. So here we can see the how the E thread it is, K thread, and then TEB. So next we can go to the Linux threads. So what is the Linux thread? Linux refers to them as a um, it is done through the cloning system called. See, these are some things which will be supported by the Linux. Okay, so clone FS and then clone VM. This is clone. Not only clone is present in that. So this is some advantage. That means some extra features that we have in the Linux. Okay. So clone FS means the system information is shared to the clone VM. The same memory space is shared, and then clones. SIGHAND means the signal handlers are shared, and then clone files means the set of open files is shared. So this is how we are sharing the data by using this clone. Okay, so this will be shared to the some other processes because sharing is another important factor, right? When you're creating the thread and all, so sharing the data is another important factor. So it is achieving through the clone here in Linux thread. Okay, so this is the structure. So these are some of the extra threads. So not only these threads we are separately using in the Linux. So most probably all the threads that we are commonly using for the Windows and then Linux. So it is a commonly some threads are available. So more than that, we are using some other threads like clone, and in that we are using the E thread, which is uh, commonly we are applying for the Windows. So this is all about the threads. Here we can complete that threads. Next class, try to solve the problems. Okay, so the problem is questions. You can recall the questions which has done the GATE examination. Okay, so related to the topics, what are the topics we are covering in the operating system? What are the questions they have already for the past years, so that we can recall it, and then we can try to solve it all the questions. Okay, okay. So here I end up this session. Thank you for attending. So for hope you will support for the future classes and all. Okay. So thank you. You all can leave now. Thank you.